So the first question is, with reference to velocity and acceleration, describe uniform circular motion. Okay, so for 2 marks, you should always remember that velocity's magnitude is always constant, and acceleration towards center and perpendicular to direction of velocity. So you got to write this. Now, it says 2 cars moving in a horizontal circle. One car follows the path X, okay, and the other path Y. The radius of path X is 318 and path Y is parallel to. Both cars have mass. The maximum lateral sideways friction force that cars can experience without sliding is same for. The maximum speed at which the car on path X can move around track without sliding is this. So you got to find F. So that should be F equals to mv squared over R. So basically friction is providing this and we got to find this. So mass of the car was 790. Speed of the car was 94 square. And R was 318. So, second please. So this should be about 22,000 newtons, right? Now, it says both cars move around the track. Each car has the maximum speed at which it can move without sliding. Now, you guys need to understand something, that to move in a circle, without sliding, I think this centripetal acceleration should be same. Maximum speed of y can be greater than x. The reason behind this is that f is equal to mv square over r, right? So because y has a greater radius. So greater radius means greater speed can be achieved. Time taken for 1 lap. So of course he has to move more distance. So it should be greater as well. Now,
सर इसमें क्या कहते हैं, कल जो हमने क्वेश्चन करा था उसमें तो वेलोसिटी चेंज हो रही थी बार बार.
कौन सा वाला क्वेश्चन है?
वो एक
वेलोसिटी चेंज हो रही थी. व्हाट डू यू मीन?
एक कार जो है वो सर्कुलर मोशन में जा रही थी.
अच्छा.
उसके वो लेकिन उसके अंदर क्या कहते हैं, वेट एक्ट कर रहा था, वेट और normal contact force.
That is vertical. This is horizontal. Entirely different thing. वो vertical circular motion था, ये horizontal है, right? Now, gravitational potential you guys should know. Hands away now. Work done. First mark for work done per unit mass. The second mark for moving this mass from infinity to a point within field. Okay, 1, 2. Now, the Earth and Moon can be considered isolated. Okay, fine. So they have given us the distance, the masses. Point P is on the line joining center E, where resultant gravitational field stands 0. So this is the null point, right? At the distance x from the center of Earth, how is it possible for the gravitational field strength to be 0 despite presence of two masses nearby? So you guys need to understand that gravitational field strength is a vector. Number one. Number two. So it can be 0 where both have equal magnitude and opposite directions. That's one. Okay. Now, show that x is approximately 3.5. Okay, so we got this, we got to do here. That's pretty simple. So at this point, we could say that this is the gravitational field strength of Earth, and this is the gravitational field. Oh, should do. G of Earth should be equal to G of Moon. So I'm going to write it like this. Gm over square equals to Gm. This is Earth. This is Moon over R Moon square, like this, right? So now G and G don't matter really. Mass of Earth is 5.98 times 10 raised to 24. And the radius to this is x. Whereas this is 7.35 times 10 raised to 22. And this would be 3.84 times 10 raised to power 8 minus x. And this should be squared, and this should also be squared. Now, ideally, I would not want to find this square. So what I will do is, I'm going to take under root on both sides. That's the easiest way. Okay. Okay, who's making noise? So much noise. Heather, my God. Okay. Now we take the under root. Under root basically helps us figure out a lot of things actually. So what I'm going to do is, I'm going to write it like this. 5.98 times 10 raised to 24 divided by 7.35 times 10 raised to 22, and x over 3.84 times 10 raised to 8 minus x is going to be free from that, right? So we don't want variables. And then I'm going to write 5.98 times 10 raised to power 24. This is 7.35 times 10 raised to power 22. Okay, so this is 9.02. And then you can multiply this and x. So much calculation. Times 10 raised to power 8. Okay, good. So I'll do it, rest I'll do it here. So 3.46 times 10 raised to 9 minus 9.02x equals to x. So I'm going to take it there. And it is going to be 3.46 times 10 raised to 9 equals to about, 10.2x. So divide by this, and it will be exactly 3.46 times 10 power 8, which of course can be written as this. So hence proved. So you could always do this. All right, now let me know if you have a question. Then it says calculate the gravitational potential at point P. Now this is interesting. So whenever there are two bodies, you have to find the potential of Earth at P and the potential of Moon at P. So if you do that, and then you will add them together to get the potential. So what you're going to do? The potential of Earth at P would be minus Gm upon R. So now because we have R, right? So that's something. So this will be minus 6.67 times 10 raised to minus 11. The mass of Earth was 5.98 times 10 raised to 24. And you will divide the distance, which is 3.5 times 10 raised to 8. We just found out. Okay.
It's 1.14 times 10 power 6.
Okay. 1.14 times 10 power 6, right? Joules per kg. And this is moon. Now we're going to do it for moon. So minus 6.67 times 10 raised to minus 11 times 7.35 times 10 raised to 22 divided by the distance you got to calculate it. So you got to minus it. What do we do? What do we do? If we subtract this from 3.5, it will be 0.34, right? Is it? Yeah. So you got to subtract it. 3.84 times 10 raised to 8 minus 3.5 times 10 raised to 8. So what is the answer then?
So I got 1.44 times 10 power 5, but my final answer is wrong. So
This is 1.44.
yeah, times 10 power 5.
Okay, so that's fine. No worries. So you got this, and now what you do? You got to find. I said these values should be negatives. I don't know why you didn't tell me negative, but this should be negative. Potential is not in positive. Now it says what is the total potential. So potentially you got to add these two. So negative plus, sorry, negative. And this is so it is 1284000, which is 1.3 into 10 raised to 6, and has to be negative. Negative 1.3 times 10 raised to 6. Do you guys understand this? All right. Any questions?
Wait, sir,
So
difference निकालने के लिए एक को ऐड नहीं करेंगे मतलब
yes, so difference थोड़ी निकालना है. It says the potential. Calculate the gravitational potential at P. So you got to add the potential there. We're not finding change in potential. We're finding the total potential. You see? Okay, good. So now let's go to the next. Next is define specific heat capacity. So heat capacity can be written as thermal energy required per unit mass. Because it is specific, you got to write this. Okay. To change one kg mass temperature by 1 Kelvin. This is what you should write. और सेल्सियस भी आप लिख सकते हैं, और आप लिख सकते हैं यूनिट टेम्परेचर. Now, a seed container, okay, whatever. State an expression to PV and Boltzmann constant. PV equals to NKT. So that should be your answer. For the thermodynamic temperature, okay, so T should be the subject. Okay, then it says show that the mean translational kinetic energy is given by this. Fine. So what you do? PV equals to NKT and PV equals to 1 by 3 NMC square. You already know this. So you equate them. So NKT equals to NMC square. So this and this cancels out. Oh, where is 1 by 3 then? 1 by 3. Here it is. So you multiply 3 there, so it will be 3 kT equals to mc square. Then you multiply half on both sides. This will be 3 by 2 kT. This will be half mc square, which is the kinetic energy. So proved. Now explain why the internal energy of gas is equal to total kinetic energy of the molecules. Because you guys need to understand. दो मार्क के लिए लिखना ना. Okay. पहले हम लिखेंगे internal energy U is equal to the sum of kinetic plus sum of potential energy. This is for 1 mark. Now, because this is a gas, since in an ideal gas, potential energy equals to 0, hence internal energy is solely kinetic energy. Do you guys understand this? Or you could say 3 by 2 kT or NKT. Now, gas is supplied with thermal energy Q. Explain with reference to first law thermodynamic why increase in internal energy of gas Q. So, okay, so basically, the change in thermal energy, so increase in internal energy is basically equal to heat supplied Q plus work done on the system. Take it up. Now this is for 1 mark. The second mark should be that reference to increase in internal energy, right? For constant volume, work done is 0, hence heat supplied equals to increase in internal energy. So that's what you got right, okay? If you have any questions, please let me know. Now, in this question, it says use the expression B2 and the information show that the specific heat capacity is given by this. Now, specific heat capacity is Q equals to MC delta T, right? Whereas, इसको हम बना देते हैं Q over M delta T. So this is what we need. We need this. Somehow I need K in this, and I need. So the previous thing was 3 by 2 kT. Impressive. So what I'm going to do is, for change in internal energy, it will be 3 by 2 K, change in temperature. And this is basically supplied by the heat energy Q, right? So we just, I'm just thinking. Okay, never mind. So then what you do I'm gonna replace T with basically Q upon 3 by 2K. Right. So if I do that, then Q over M, this will be Q, 3 by 2K. This will go up, so it will be 3 by 2K over Q, and Q will cancel out over M. Okay, we got it. 3 by 2 Km proved. Is it clear? Now, the container is now replaced with one that does not have a fixed volume. Instead, gas is able to expand. So the pressure of gas remains constant as the state is the reason how specific heat capacity of the gas would compare with the value of this. Achha, now you guys need to understand something. When gas expands, right? Work is done on the surroundings. So basically, to raise temperature, we need to supply larger amount of heat. Hence, of course, if you're supplying more heat per unit, temperature rise, then specific heat capacity will increase like that. Okay, please do remember that. Or increase नहीं will be bigger.
सर ऐसा क्यों है कि ज़्यादा एनर्जी चाहिए होगी थर्मल एनर्जी?
क्योंकि the heat that you're supplying is used for two things. One, it is changing the temperature, I mean increasing the internal energy. Also, it is doing work on the surroundings. Do you see? So you need that energy to do two things: change temperature and work. So you will need more energy. More energy means greater thermal capacity for same temperature rise. Do you understand?
Yes, sir.
Okay, then. So classic question. Initial amplitude of the oscillation. So initial amplitude, you just need to make a line because they haven't given you the equilibrium. And initial amplitude will be 5 centimeter. Okay. Then it says angular frequency. So omega is angular frequency. I don't know if they have the time. Yes, we have. This is 4 seconds. 4 seconds, fine. So 2 pi by 4. What is it?
1.57.
1.57 radians. Okay. The maximum speed V in oscillate. So maximum speed has a formula V naught equals to plus minus omega x naught. Well, when you square it off, so this plus really doesn't matter. It doesn't really matter, but chalo. So maximum speed omega is 1.57 and the displacement is 5 थी ना, so 5 into 10 raised to power. अच्छा, centimeter में देना. Okay, and then the answer will be
7.85.
7.85. Apart from the quantities in describe what may be deducted in 4.2 about the motion trolley between this and this. No calculation required. T0 to T24. So first till about this time 12, it was going smoothly and then it is being lightly damped, right? So how many marks is this? 3. Okay. So for 3 marks, Okay. So for 3 marks, we could say apart from quantity described, linear described. So we have already found amplitude. We already have found the angular frequency. What we haven't found is we found the time period. So basically 20, it's its equilibrium, we can say that. And if it goes, this is the length it is talking about. Right. So when it is there and it is reducing from the start, at 0 it was 25. And then, right. So it means it was pulled to this side. So this was increased and then came back. Okay. Now I got the 3 points. So you can write that the car started from right 5 centimeter to equilibrium. 8 point. Then you could say that basically the equilibrium is 20 centimeter. And then you could also say that after 12 seconds, light damping was shown. Is it clear? Now, then it says length or iska banao. So speed at when it was 0, when the displacement was really 0, right? So the speed was should be maximum, and the speed we calculated was 7.85. So we have to go there. I think this is 7.5, 7.6, 7.8, and 7.85. So it is here. So at 0, the speed was right here. I'm going to rub all of this. And when it was the maximum displacement, when the length was, okay, wait. When the length was 25, when the time was 0, when the length was 25, so the speed was 100%. So speed is 0 between 15 and 25. Okay. Okay, so I gotta make 15 and 25. Well, how are we going to show two values? This is important. 7.5, 7.6, 7.7, 7.8, 7.85. Okay. So when the speed was maximum, so the length was, the speed was maximum, the length was 20. So it should be right here. And when 20 पे speed ऊपर होगी, so I think right here. And then 15 पे 0. So it should be like this. This. It should be like this actually. Is it clear? Circle बनेगा.
So wouldn't 7.9 be lower?
7.9 is lower. 7.9, 7.85, yeah. 7.9, I was doing it for 8.5, but you could take 7.9 here. What? This is not correct, right? My
so
God.
either way, it is not 7.9 as velocity. I don't know what.
Sorry, this was 6. This was 7, right? This was 8. Yeah. So somewhere here. It should be somewhere here. I did it wrong. Okay, here. And about the same 7 point, I mean 6, 6, 7, 8, somewhere. So now it will be like this. But it still will be a loop or circle like this. Is it clear?
Yes, sir.
That's cool. Okay. Then going to the next thing, this is not required. Although this was very easy once upon a time. Not required. What is this? Capacitor. Okay. So this is a capacitor is charged by a supply. So there's a potential difference V between the plates. State an expression of this CV. What is E? E is the energy stored. Half CV square. Okay, that's pretty simple. So it says at the capacitor discharge now disconnected, supply the plates of the charge capacitor is now disconnected, supply the plates of the capacitor initially separated by distance L. They're moved together. Okay. State an expression of the new capacitance in VLT. Okay. Well, that's something actually. Q is equal to CV. So now I gotta think. Let me think. Now, if you look at it, why? The charge will be the same. These two are going to change for that matter of fact. If the charge is going to be the same, so the new charge will be new capacitance and new voltage. Okay. Now the new capacitance is required. So Cn Vn equals to Cv. Okay. The new voltage, because distance is gone, like it's smaller. Voltage, how is it related? V upon D. Voltage, electric field strength is basically voltage over the distance, right? So it means voltage is proportional to distance. If it was, what if the previous voltage had a distance L, the new voltage would have a distance L minus D. Okay, so that's proportionality. So we can use it, right? Okay, so we can use Cn L minus D, and with this respect, I can use Cn. So then Cn is going to be Cl over L minus D. Oh my God. This is one hell of a question. Okay. Do you guys understand what I just did? If that was not too confusing.
Sir, Q सेम कैसे है?
Because चार्ज तो उसके अंदर स्टोर हुआ है ना, चार्ज तो स्टोर नहीं, मतलब चार्ज रीलोकेट हुआ है ना, रीडिस्ट्रीब्यूट हुआ है. सो जितना चार्ज था वो सेम रहेगा पहले भी बाद में भी. Yes.
Oh, हाँ सही बात है.
Sir, but if
Yes.
this was in terms of energy, then it would be different, right? Because then it would change.
In terms of energy, yeah, might be, but then it would be the same thing. Energy V upon, no, it would not be. It would be the same formula, because double M energy and voltage are also proportional.
Oh, okay.
So it's the wrong, like, sorry, this is not energy, it's VQ. Charge is the same, they're also proportional. So it doesn't matter. Now, new charge on one of the plates. Yeah. Yes. Yes, yes.
सर ये कहा था in terms of CV, मतलब V तो आए नहीं फॉर्मूला में.
वो मैंने रेशो लिया है ना, मैंने इस फॉर्म इलेक्ट्रिक फील्ड स्ट्रेंथ से मैंने लिया. इलेक्ट्रिक फील्ड स्ट्रेंथ B और D आपस में डायरेक्टली प्रोपोर्शनल है, राइट? सो कैन आई राइट इट एज दिस KL प्रोपोर्शनैलिटी खत्म कर दी। मानते हो तुम? और जो न्यू भी है उसको हम लिख सकते हैं k टाइम्स l माइनस t, क्योंकि ये डिस्टेंस निकालते हैं ना, डिस्टेंस बिटवीन प्लेट्स। अब तुम इन दोनों को रिप्लेस कर दो उस फॉर्मूला में, k कट जाएगा, बाकी रह जाएगा। ओके, चेक करो। Cn k l माइनस t, c टाइम्स l k l, k और k कैंसिल हो गया, Cn इज इक्वल टू Cl ओवर l माइनस t, लाइक दैट। ओके, नाउ जैसे मैंने बताया कि चार्ट सेम रहेगा, so it will be the same, it will not change, q is equal to cv रहेगा, and then the new potential difference Vn between the plates. Now you need to find this, right? अब new potential difference कैसे निकालें? So V Qn equals to Cn Vn. That is also the same case, right? Now if I think correctly, this will be Cv. Cn हमने already find कर दिया, that is Cl over L minus T, and Vn is what we need to find. So C and C will cancel out, we'll take it there. So V times L minus T over L. It basically, this question has no sense, right? Like it has no sense in physics, it's just maths. This should be the answer, I think. L minus T over L. Now, explain whether reducing the separation of plates result in increase or decrease of energy stored. Now, this is a question. Now, you guys need to understand something. And when you separate something, right? So basically, these are oppositely charged plates. So their forces are actually acting like this. They're attracting each other, right? So if you separate them, so you're doing work, right, against the force. So you're increasing the stored energy. When you do work in the favor of force, you reduce the potential energy, right? So I'm just going to write it as a note here, so you guys remember. Work done against a force, okay, increases potential energy, whichever potential energy is this. अभी हम electric potential की बात करें. Work done in favor of force decreases potential energy. Right now, we just brought them closer, and the force between them is also in the same direction. So it means that we're doing work in the favor of force. So we're going to write, since, so I'm going to write decreases, as the plates brought closer attract. That's fine. Okay. So do remember that this is the most important thing. Everywhere potential energy works like this. Like you see, in gravitational potential energy, this is a mass. If you take a mass away, this is the velocity. The force is this, so you're doing work against, so its gravitational potential energy is going to increase. See, you're doing against it. If this is a charge and you do a smaller charge and you move it away, not closer, because the force is here, so its electrical potential energy increases. Do you guys understand what I'm saying? If on a spring you move, you apply a force here, you basically move it away. Like if the force is acting this way, you're actually trying to, the spring wants it to come back to equilibrium, but it is moving in this direction. So its elastic potential energy increases. So always like that. Now, state 2 problem, oh, we don't have to do this. Define Tesla. Now, Tesla, you have to define it in the terms of units. So you know that force is equal to BQB. If I were you, I would first segregate B. It will be force over charge over velocity, right? So I'd say force is Newton per बल्कि Q से नहीं पर कूलम नहीं इसने या पर कूलम लिख सकते हैं पर कूलम per meters per second where the charge is moving perpendicular to field. So you can also use F equals to PIL, then you can write like force per ampere per length. So you can use that too. And then instead of charge, you can write current. Okay. Then they have shown that Newton.
Sir?
Yes.
I wrote Newton per ampere and per meter. Is that okay?
You wrote what?
Newton per ampere per meter.
Yeah, because you use F equals to BIL, so that's fine. But then you have to write, instead of charge, you got to write current. Okay. So otherwise, you won't get the other mark. Now it says there is a magnetic field in the wire. There is a frame. I don't know what is happening in this for some reason. You know? The ends of the frame are connected power supply. I have no idea what is happening. Chalo, let's see. Determine the magnetic flux density. So it's 50. We got to use F equals to BIL sine theta. Why? Because current is this. So I don't know what was the force. Did they talk about force anywhere? 1 millinewton. Okay. 1.0 times 10 raised to minus 3. B current was I think 5, if I'm not wrong. And the length has to be the perpendicular length. Okay, so this is PQ length, right? No, PQ length. 0.6 means 0.06 meters and sine of. Has somebody done it? No? Oh, they've already asked in millis, so you don't need to do this. 1 divided
4.4. 4.4.
Okay, 4.4 millitesla. That's good. State with reason whether the change in reading on the Newton meter is an increase or decrease.
Sir?
Yes.
Sir, I wrote 4.35.
That's fine.
Okay.
No bad. So then it says, what is increase or decrease? State a reason whether change in reading on the Newton meter is. Now the current is going like this, right? You know? Magnetic field is like this, current is going like this. So it will actually have a force out of the page. If the force is out of the page, wait a second. It is going into the page, it is above. Okay. Sorry, force is not out of the page. Into the page. Magnetic field into the page. Current is towards the right, force is upwards. So force is upwards. Right. So then Newton meter ki reading pe kya effect hai? Where is the Newton meter? If the force is upward, so it will be lower then, right? So you can say force according to Fleming's left-hand rule. Please don't be like me, write the full form. Is upwards. So reading on Newton meter decreases. Okay, then the frame is lowered further so that the vertical sides start to enter the magnetic field. Suggest what is affect this? I think that if the flame is frame is lowered, the magnetic field is like going into the page. So let me check. Into going down. So the force on this will be on this side. Into going down, into going up. Force on this will be this side. And there's a string. Okay, I think it's going to just go like this. Going to turn. Okay, so it means that all right. So it means that the forces will cause the wires to turn. Not the wires, but the frame. All right, like this. Pretty simple, I guess. Now, then question number 9. By reference to power dissipating resistor, what is meant by RMS value of alternating voltage? Okay. अच्छा, RMS के दो चीजें याद रखनी है. Voltage of constant value, number 1, and number 2, that produces the same power output as the alternating voltage. Now, it says,
sir.
Yes.
सर आपके नोट्स में ये जो आरएमएस की डेफिनेशन है वो मैं पढ़ रहा था, उसमें लिखा होता है कि पहले ऑल्टरनेटिंग करंट इज फर्स्ट स्क्वायर्ड देन एवरेज, वो वाली डेफिनेशन थी.
That this produces the same power output as the mean power of alternating voltage.
सर हम वही लिख सकते हैं, मतलब पहले स्क्वायर करते हैं बाद में उसकी एवरेज निकालते हैं फिर
वो एक्चुअली मेथड है, वो मेथड है आरएमएस का कैसे करना है, वो नहीं लिख सकते. एंड
तो अच्छा डेफिनेशन ये है. ओके सर.
The coil is rotating freely on friction bearing at a constant speed in a uniform magnetic field. The rotation causes an induced EMF across open terminals. The induced EMF has the RMS value of 12 frequency. Speed of rotation now doubled. State explained with the reference of principal electromagnetic speed. Okay. If you know the electromagnetic spectrum, you guys need to understand that the rate of change of magnetic flux also doubles. अगर ऐसा हो गया था, because EMF is equal to change in magnetic flux linkage over time. Now, so doubles. Okay. So पहला point, दो point है. So then, of course, the RMS and the peak voltage will also double, because अगर आपका time जो है वो half हो रहा है तो EMF half double. That's why. Okay, so do remember that. Now, figure sketch the variation time t induced EMF across terminal of the coil increase speed of rotation. Your line should extend from this. Pehla jo tha na, I don't know they have given up anything like that or not. So they said first the frequency was 50. If this coil speed is doubled, it means the frequency is going to be, I guess, right? And voltage bhi aisa ho jayega. RMS voltage 12 hai. Let's find the peak voltage. So RMS voltage is peak over under root 2. So this is 12 times under root 2 equals p. Can you find this, please? Let me know. What is this?
17.
17? 17. 17 volt. इसका मतलब ये कि when voltage is going to be doubled, so 17 into 2 is 34. So our peak तो मिल गई हमें, right? Now it says the frequency was 50 hertz. 50 hertz का मतलब ये है the time period would be 1/50. Can you find what is 1/50? I think 0.2. 0.0. 0.02 is this, right? So अब डबल करने से frequency half होगा, मतलब डबल होगी, time period half होगी. यानी it means whole wave here. So we got to go to 34. This is 20. This is 30. 31, 32. Okay. 32, 34. And 32, 34. So it will have a peak at this. Or no. No, it won't have. It will have a peak at this point and at this point. So you're going to make it like this. And make sure you make 2 cycles. Like this, right? All right, now, then, then you go to the next class, state and explain the effect on the motion of the coil of connecting a load resistor across terminals. Okay, so when you do this, so if I create a load resistor, if I put a load resistor against the coil, you know it is going to increase the resistance, which means that, okay, right. So load resistor increases resistance. 1, 2. So the current will dissipate heat energy across it. And then if that happens, then coil would stop rotating because the energy is going out, right? Now, any questions? Please let me know. Then comes state the experimental phenomena that provides evidence for the particular nature of electromagnetic radiation, photoelectric effect. The wave nature of matter. Electron diffraction. De Broglie wavelength. A matter moves with momentum p. State the equation that gives effective wavelength of particle. State the name of symbols used. So the wavelength equals to h upon p. And this is Planck constant.
Electron diffraction की जगह मैं Young's double slit experiment लिख सकता हूँ?
नहीं. You cannot. क्योंकि electron diffraction ही आपको दस रही, right? Name the wave. चलो ये तो लिख दिया हमने, फिर से लिखते हैं. Only particulate nature of wave can be shown through electron diffraction. Now, electrons are accelerated from rest through potential difference of this, so that the final speed. So, energy, electrical energy goes to kinetic energy. 4.8 times 10 power 3. Charge in electron is 1.6 times 10 raised to minus 19. Half times mass of electron is 9.11 times 10 raised to minus 31. And V square. And I believe the answer should be this, right? Can you confirm? Okay. I think it should be the same. Can you please confirm, anybody? Okay. Now, yeah, good. Now calculate the effective wavelength of beam of electrons at the speed. Now this is equal to h upon p. So this is 6.63 times 10 raised to minus 34. Mass of electrons is 9.11 times 10 raised to 31, and the speed we just found out. Okay, then answer is. So this basically what this shows is that you guys haven't. A lot of people haven't done anything. This is what it shows. Okay, then state the X-ray image. What is meant by sharpness? Sharpness is basically how clear the edges can be distinguished. The edges can be distinguished. I hope that is spelling. Now, contrast is the difference of blackening of different structures. So how black is something? So you can also write degree of blackening. Now, the parallel X-ray beam passes through a thickness of this of a soft body tissue. The intensity emerging of the beam is 12% of the incident. So there is a tissue. The intensity was, let's say, I naught, and when it emerged, it was 12% of I naught, the new intensity. Then the length usne got 2.3 centimeter, and calculate the linear attenuation. Give a unit to your answer. Fine. I equals to I naught E minus mu X. I is 12, 0.12 I naught E minus mu, and let it be 2.3. So I naught and I naught cancel out. ln 0.12 and minus mu times 2.3. And the answer is 0.92, and centimeter minus 1 should be the unit. We took it in centimeter, right? That's one. Meter
मैंने convert करके 92 per meter लिखा था.
So ठीक है, that's fine if you convert it. In medical diagnostic, X-rays may be used to produce single X-ray image, or may be used in computer tomography, CT scanning. So there's an advantage and disadvantage CT scanning compared with X-ray imaging. Oh, cool. Spell advantage is that CT scanning produces 3D images. It's one of its properties, right? And the biggest disadvantage is that it causes greater exposure to patients of X-rays. That's not a good thing. Okay, then question 2. Define radioactive decay constant. Decay constant is the probability of decay per unit time. I think this chapter is easiest. Now, the sample of radioactive as an activity determine the decay constant of iodine. Okay. So you have the mass and activity and MR, and you want to find decay constant. So first of all, to find decay constant, we need to use lambda n. We don't have n. To find n, we'll use moles. So moles is n upon Na, but we don't have moles. So to find moles, we can use MR, M in grams over MR. Now what you do? N will be equal to 5.87 times 10 raised to minus 7 grams. You have to change this into grams. Remember that. Okay. Then multiply by 6.02 times 10 raised to 23 and divided by MR, which is 131. So what you get as n?
1.1 times 10 power minus 6.
Or come again? 1 point?
No, sir, that's the final. So 2.698 times 10 power 15.
2.98 times 10 power 15. That's what you get. Okay.
2.698.
2.698. Okay. What you do then? Activity is 2.92 times 10 raised to 9. You divide it by 2.698 times 10 raised to 15. And the answer is
1.1 times 10 power minus 6.
okay, that's cool. So we get the answer. Pretty simple, right? Now, suggest 2 reasons why detector placed in the sample would record a count rate much less than this counts per second. अब इसकी बहुत सारी हो सकती है, ठीक है? एक तो you know, one of the points is that there could be something wrong with the detector. Or maybe it is getting absorbed. So हम लिख सकते हैं some radiations do not reach or get absorbed because alpha particle is very, say, ionizing, so it can ionize air as well. So a radiation do not reach or get absorbed by air. And the other thing could be, detector may not be 100% efficient. And third point, that radiation is happening in all directions. Okay. Ta-da! Finish. Any questions, please? Let me know. Lisa, आप कल नहीं आई? खैरियत थी?
Yes, sir.
Okay. Lisa को रोजा लग रहा था, like चले आज छुट्टी कर लेते हैं.
नहीं, sir, it's